This is question 6. We want to calculate the volume of this solid and write the answer correct to the nearest cubic centimetre. So the first thing we need to do is look at what shapes we have. We can see we have a small cone here which has been removed from the top of a larger cone. That's a frustum, or a truncated cone, as in the previous example. So let's get the volume of the large cone first. So we've got the formula, which is 1/3 base area times the height. So 1/3 the base area. This is your base, so pi r squared times the height of the cone. 1/3 pi r. Well, the diameter is 10, so the radius must be 5. So that would be 5 squared times the complete height. 9 plus 6 is 15. That's the height of the cone, including the part that's been removed here. So 1/3 pi times 5 squared is 25 times 15. And for the large cone, that will give you 125 pi. I'll leave it in terms of pi at this time. And for the small cone, V2, our volume would be 1/3 pi r squared height again, which is 1/3 pi. Now the radius in this case is going to be 2. Half of 4 is the diameter. So that's 2 squared times the height of this cone, which is 6. So we'll have 1/3 pi times 4 times 6, which will give us 8 pi in terms of pi, both volumes. So we need to remove this small cone from the large cone. So it will be V1 minus V2 will give us our final answer, final volume. So V1 is 125 pi minus the small cone, which is 8 pi, which is 117 pi. And converting that to a decimal, 367.57. And we wanted the nearest cubic centimetre, so that's going to round up to 368 cubic centimetres. And that will be our final answer there for the volume of this solid here, this part.